Hi, welcome to clickmyproject.com. Now we are going to see the process of an important energy efficient price driven request dispatching for cloud data centers. So in this process, overall we are going to watch out the energy price driven request dispatcher that forward the client request to the data center in an electric cost saving way. So actually this process deployed of consists of the data centers and virtual machines and the cloud broker. The data center in which all the virtual machines are executed, and cloud broker which establishes the relationship between the users and the DNS servers. So actually the DNS servers forward the request to the data centers only by means of the distributed hash tables in which the mapping process haven't happened for the scalability and availability. Actually the electrically cheaper data centers in which all the virtual machines are executed as a result. And in the overall process we balance the loads and do the scheduling operation for the electric, and also we calculate the power consumption for the overall energy request price driven process. Next we are going to see the process flow of the whole project. Here first we have to create the cloud environment in which the jobs are created. After the jobs are created, we have to find the characteristic of them, for example its memory capacity and its power consumption, so by means of distributed hash table. After finding that characteristic of the VMs, we have to dispatch the jobs based on actually the cloud jobs are dispatched based on how much power it has been consumed, it has been measured in. Then after that based on the power of our job allocations, all the jobs are allocated in the and in the respective virtual machines which has been established by the respective data owners. And after that jobs allocated and it has been executed in the remotely. If it has been after the job has been executed, the performance analysis of all the cloudlets has been calculated. At last we obtain the results. Next we are going to see the demo of this process. First in this package we have to run the details.java. So after running the process, here we are working on the cloud sim environment, so in which we have to create first we have to create the simulation environment. For that, just give the data center dynamically, so and enter the brokers dynamically, enter number of users and enter the cloudlets. Here the cloudlets represents the number of jobs you have been entered. After the virtual machine, here the virtual machine which is used to execute the given jobs. Now after creating it, I'm just given the process. Here after creating it has been created in this virtual machine. Here the two data centers have been created. Power data center has been created. After that, the cloud broker has been created in with this cloudlet ID, the respective cloudlet ID which is used to denote these jobs of the different lengths. Now after creating that cloudlets, we have created the virtual machine which is responsible for executing the overall jobs. With that it has been created the respective IDs, and after that we have created the jobs which is responsible for the execution of the inputs. And after that we have been calculate the load. We have predicted the load based on the bandwidth latency and its CPU cycle speed and the length of the jobs and the current load, which has been estimated based on this each and every jobs which has been submitted in each and every virtual machines. The parameters are the here we most important parameter is the bandwidth latency and its current load and its length. And after the load predictions, we compute the cost. So the cost is based on the it is a utilization formula, so it has been calculated for each and every item. Then we have set some cost constraint. Based on the cost constraint, we have select the best VM in which the jobs have been executed. before submission of the jobs we have to perform the some scheduling process. So here all the jobs are scheduled and it has been executed. So we have done the load balancing on the executions. Here all the jobs are executed and submitted in the cloud sim environment. It has been generated. Here the total cost and all the scheduling process has been generated. So for the power, here all the power consumption operations have been done. For example, here you can see that all the virtual machines have been submitted the jobs to the respective host on the virtual machines, and its PE calculator. PE refers to the processing elements in which all the jobs are submitted host by host, and the MABS reference the million instruction per second. Here all the power data centers have been created and has been submitted to the electrically cheaper. They have been scheduled in the way that all the jobs are redirect or executed by means of that electrically cheaper prices. And after that, at last we got the output of. Here we created the host of 50 and the virtual machine 6, and the total simulation time is 86,400. At last the overall energy consumed have been measured in kilowatt per hour. At last where the graph have been generated. The graph is based on how the total energy consumption, and also this is the expected energy consumption of the overall simulation environment, and we achieve the electrically cheaper job power consumption of the each and every cloud which has been executed in the cloud sim environment. Overall we have redirected the electrically cheaper client request to the data center, in which we reduce the energy consumption of the overall cloud process. Thank you for watching.